Hello, welcome to assignment 5 for DATA610 Decision Management Systems. This is a team analysis using Cognos Analytics. My name is Damian Reyes and my teammate is Gregory Antrim. All right, let's go on to the first slide. So here we have our first display. We have a map of the world and we are mapping life expectancy by country. We have a slider down here for the year, and we have a summary up here for the life expectancy. So one of the interactive features here is that we can play through the timeline here using this player here, and we can see how life expectancy changes by country. And we have a summary up here as well, which will give us the average life expectancy for all countries. So let's pause that, and then on the left side here we can choose any particular country. For example, we can choose the United States, and then we can zoom in. And once we choose a country, the summary up here will change. And we can select individual years. You can see how the life expectancy changes. And then we can do the same for any other country, even by selecting it on the map. So this is a useful tool to see or to get a summary or a general overview of how life expectancy changes through time and geographically get an idea of what countries have good or bad life expectancies. You can see mostly Africa is or has one of the lower life expectancies here by looking at this legend down here. You can zoom in, see other countries as well. So here in this next scene, we have two line graphs. One of them is life expectancy by year, and the other one is pretty much the same, but it is split up by country status. So we have two types of countries in this data set. We have developed and developing countries. And we can see the breakdown here. About 16.5% of the countries are developed, while 83.5% of the countries are developing. So the majority of countries are categorized as developing countries. So again, we can see a overall upward increase in life expectancy, which is good. But looking at the split down here, we can see there's a huge difference between developing and developed countries. If we look at the graph down here, we can see there's about 10 to 12 years difference between developing and developed countries. So as mentioned before, these are interactive. So if we click on any specific data point, it will change all the other visualizations accordingly. So if we want to just look at developed countries, for example, we can see the life expectancy changes drastically here in this pie chart. Let's go back here. So we can see, based on this legend, the lowest life expectancies here, they pretty much disappear if we click on developed. And we can see most of the life expectancies fall within this four ranges here. Then looking at the other case, if we click on the developing countries, we can see we have all these data groups back. And then we can also click on individual data points here to narrow down a specific year. So, for example, in 2005, if we click on that, we can see the split out of life expectancies, and we can click through and see how they change. So if we click through these data points here, increasing the year, we can see the life expectancy pie chart update, and we can see that higher life expectancy age groups are getting bigger, while the smaller ones are either disappearing or becoming smaller. All right, so let's put it back and move on to the next scene. So in this scene, we have more or overview of the data. In this case, we're looking at GDP per capita, which is the gross domestic product. And the first chart here, we have GDP per capita versus year, and it's split out by country. So I wanted to show this to the user because we can clearly see some outliers here for Republic of Moldova and for the Republic of Korea. They are much, much higher than any other countries, and they have a linear decrease over the years, which almost seems like this was just an estimate or incorrect data, since these small countries can't possibly have a higher GDP per capita than the developed countries. So let's look at the graph down here now. Here we can select on the left any individual country we want to look at. So if we click on Mexico, for example, we can see how their GDP per capita changes over the years. And it's interesting to see what these countries have for GDP. It doesn't seem like many of them are very linear. It looks like they have a few places where they just completely drop. But anyway, I just wanted the user to see this because it doesn't look like this data can be reliable, or maybe the method in which it was collected wasn't consistent. All right, let's go on to the next scene. So here's the next scene, and again we have another map of the world, and in this case we're mapping adult mortality and infant deaths by country. In this case the legends are different. Here we have low adult mortality in green and high adult mortality in red, whereas infant deaths is determined by the point size. The bigger the point, the higher the infant deaths. The biggest one we can see here is in India for infant deaths. And again, this is interactive, so we can click through the years. and see how these change. You can see, for example, in 2002, Russia had a huge increase in adult mortality. And again, Africa seems to be doing the worst in both adult mortality, infant deaths, and as we saw before, they had the lowest life expectancies. And again, we have a summary or two summaries up here for adult mortality and infant deaths. So if we select a specific country, like let's say for example, we select Congo here, you can see the adult mortality and the infant deaths. And we can also narrow it down by year. So for example, in 2007, we can see that they had 354 deaths for adults between the ages of 15 and 60, and that's by 1,000 people. And then infant deaths is measured again by 1,000 births. So again, this is another slide to help familiarize the user to the data set and give them an idea of what the data looks like. So let's go on to the next scene. Okay, so here's the next scene. We have again life expectancy graphed versus year. And if we don't click on any specific country, this will be for all countries. But if we narrow down to specific countries, we will see irregularities in the data. For example, here we have a major increase, and then it drops back down to a more linear increase. Some of the countries are pretty linear, but there are some, especially developing countries, I guess, will have the biggest jumps in life expectancy. And yeah, this slide helps the user get acquainted with all the trends in life expectancy. And they can come back to this at any time and see specific country, see how they change over time. So let's move on to the next scene. Okay, so this is scene 7, and we're looking at insights by health. So here we'll look at a few health factors that will have an impact on life expectancy. Here we have HIV/AIDS, and this is deaths per 1,000 live births. This is body mass index. Next we have diphtheria vaccination rates, and I think this is pretty much tetanus vaccination. And next we have hepatitis B, and in this case, this is measuring the immunization percentage of 1-year-olds. So if we look at the trends here, we can see that HIV and AIDS definitely have a big impact on life expectancy. Obviously, the higher the rate of HIV deaths, per 1,000 live births, the lower the life expectancy will be. If we look at body mass index, it's a different story though. You would expect the higher body mass indices to have lower life expectancy, but it's not the case. In this case, we have the highest class of obesity having the highest life expectancy. I think this is probably an error on the data that was collected. That's why I added a filter here for body mass, and the user can go in and change it. As we can see here, the range is from 0.9 to 87. And after doing some research, you can see that this is probably not possible. I think the lowest people can have before they have organ failure is about 12 body mass index, while the highest here, I mean, I guess these are all possible, but they would definitely not be something that a whole country is average for. So if we change these to more conservative values, you can see how the graph changes. And still, it looks like the more body mass index or the more overweight people are, the higher the life expectancy. Let's see if we can change this a little more. About 40. Yep, that changed it a little bit, but still not what we would normally think. Especially here, severe thinness, you would think would have a lower life expectancy, but it doesn't. So that's another thing, I guess, that gives the user some insights to the data. You know, maybe this data wasn't collected accurately, or there were different ratings that they were using when they were collecting the data. So next we have the vaccination rate and hepatitis B immunization. And again, we can filter all these visualizations by developed or developing. So if we select developing, we can see the graphs change accordingly. Let's switch to developed now. If we pick the developed countries, we can see there's a huge difference between them and developing countries. So we can see there's pretty much only one value for developed countries for HIV deaths. And same for body mass index. There's only, most people, or the average person is in the normal range. There's a very high immunization rate for hepatitis B and for tetanus. Okay, so again, we can also filter these by year. So right now this is all years. If we select a specific year, the graphs will change accordingly. Okay, so let's move on to the next scene now. Okay, here's scene 8. This is more health factors that have an impact on life expectancy, and these were picked up by Cognos Analytics as having or being strong drivers for life expectancy. But as we can see here, only polio immunization seems to have a correlation to life expectancy. Measles and alcohol consumption don't seem to have any sort of correlation to life expectancy. And again, the user can narrow this down by year. And they can also filter it by developed or developing countries. Again, not very easy to see any trends here for measles or alcohol. Okay, so let's move on to this next slide. Okay, here's the next scene. Here we start looking at economic and education factors that have an impact on life expectancy. Here we have income composition of resources and years in school. Income composition of resources is a human development index, which pretty much measures how developed a country is. And obviously, the more developed a country is, the higher their life expectancy. Same can be said for years in school. The more time people spend in school, the more educated they'll be, and the better overall they'll do in life. So again, we can filter this out by developing and developed countries. So if we look at developing countries, we can see there's a difference in how many years in school. Here they go up to 20.4 in developed, whereas developing it's 17.3. The same for the Human Development Index. Here it only goes up to 0.86, whereas developed countries have a higher index that goes up to 0.91. And that's just for this particular year. It'll change by increasing time. Obviously, they will get better. So if we go back to most recent year, which is 2015, it increases to 0.95, and then developing countries increase to 0.9. And again, here the correlation is very easy to see for both the Human Development Index and for years in school. Okay, so let's move on to the next slide. Here we have scene 10. This is more economic and education factors that have an impact on life expectancy. Let me unfilter that. Okay, so this is how much GDP per capita, or the percent of GDP per capita, is spent on health. So the more people spend on health, the higher their life expectancy on average. Whereas here, this is how much the government spends on health. As you can see, it doesn't seem to have any impact on life expectancy, although there's not much, not a big percentage. It's like 3.47 is the largest percentage. So we can again narrow this down by year. and we can narrow it down by developed or developing countries. Okay, so let's move on to the next scene. All right, this is more economic factors that affect life expectancy. Here we have a heat map or a tree map with a heat legend on it. Uh, and this is plotting GDP and life expectancy, as you can see here on the legend. So the darker the green, the higher the life expectancy. And obviously the bigger the square here, or the bigger the area, the higher the GDP. Right now this is filtered out by developed countries. Um, we can remove these filters and have all the countries here. So we can see definitely the higher the GDP, the higher the life expectancy for a country. If we look down here, we can see that the countries with smaller GDPs have the lowest life expectancies. And again, we can filter this by developing countries or developed countries. So as I mentioned before, I don't know if the GDP data can be or is that reliable, but we do still see that trend where the higher the GDP, higher the life expectancy. And down here, the smaller GDPs, we have the lower the life expectancies. And again, we can filter this by year. So here the user can pick out any country and we'll see exactly what their GDP in each year and what their life expectancy in each year was. See, for example, we have an outlier here, Norway. Has a very low GDP, but a very high life expectancy. And these are all developed countries right now. United States, for example, GDP on 2009 was only $6,500. It's pretty low. Yeah, the United States doesn't seem to be doing too well GDP-wise. But okay, let's go on to the next slide. So here's scene 12. This are decision tree diagrams, and this is looking at all drivers for the life expectancy data. Here's the decision tree. Here is a sunburst diagram, and down here is a driver analysis. So once we feed all the data to Cognizant Analytics, it picks out the strongest drivers to use for this decision tree, and you can see how it splits up the data. It picked up the Human Development Index first, and we can see over here in the sunburst diagram how much of the data fits in each of these categories that it's split into. So we can minimize all these and Do the same for the sunburst diagrams. We can follow along. So if we look at the smallest range for human development index, it next looks at deaths for children under 5 years old. And if we look at the smallest range over here in the sunburst diagram, we can see how the data is split for deaths under 5. And we can keep going for these two ranges and look at how data is split for these different HIV/AIDS ranges here. So we can see if we have this data, the user can follow along and try to predict life expectancy. In this case, life expectancy would be about 61 years. Over here it would be about 55 years. And the same for these ranges here. So that's how a user can analyze or take advantage of these diagrams. And moving on to the driver analysis, we can see what combination of drivers has the strongest predictive strength. And then we have the strongest two drivers, combination of two drivers. And then we have others here. Here we have a few different combinations of two drivers that have a predictive strength of 69. The highest two drivers is this. There's the Human Development Index and HIV. The single strongest driver is over here, and that is the Human Development Index. And that's basically what helps determine which visualizations to look at when analyzing this data. And as we saw before, the Human Development Index did have a pretty strong correlation with life expectancy. Okay, so let's move on to the next scene. Okay, so here's scene 13. These are decision tree models using only the health drivers. So in this case, we fed Cognitive Analytics just the health-related drivers. Unfortunately, it looks like body mass index is probably not a good one to use just because the data doesn't seem correct. As we saw before, we had really high ranges in body mass index, and we even added filters up here for only including reasonable body mass indices of between 10 and 50. I mean, even 10 body mass index is pretty much close to organ failure. So this is just to show the user what Cognitive Analytics spits out, but you still need to go in and look at the data, to see if it makes sense. So I think in this case, we're going to just go ahead and edit these to remove body mass index. Just because if we look at how it splits it out, for example, here in this case, it's saying if body mass index is greater than 22, you have a higher life expectancy than if your body mass index is less than 22. So let's go ahead and remove these. 1 second. Okay, so we're back here looking at the decision tree diagrams, but now we have excluded body mass index. So here's our new decision tree and sunburst diagrams. And this is the driver analysis down here. And as before, this gives us the combination of drivers that have the strongest predictive strength. And we can also look at the combination of two drivers. There's a couple here. There's HIV/AIDS, polio, and HIV/AIDS and tetanus immunization. And again, as before, we can use these decision trees to estimate the life expectancy given this data. So we would need to have the HIV data, alcohol data, tetanus immunization, measles immunization. We need to know how many or the percent of young adults or children that are thin between the ages of 1 through 19 and 5 through 9. And we need to know the alcohol consumption. And again, on the sunburst diagram, we can see how the data is split up. If we minimize these, we can see there's pretty even split in the first factor, which is HIV and AIDS. And then the next factors, you can see the data is still split sort of evenly, so the user can use the sunburst diagram to see how much of the data fits in each of these categories. Okay, moving on to the next slide, or the next scene here. Okay, this is scene 14. This is the last slide. This is looking at decision diagrams using only socioeconomic drivers. So once we fed the data to Cognitive Analytics and we narrowed down the drivers to just the socioeconomic ones, these are the ones that it picked up as being the most or the strongest or having the strongest predictive strength. And again, these are what we used for the previous visualizations. You can see here the strongest two drivers is the Human Development Index and how many years in school. The next two are the Human Development Index and the GDP. The strongest single one is the Human Development Index. So again, we have a life expectancy sunburst diagram. You can see the split out of data, how much data fits in each category. This one's very similar to the first one since it's using that Human Development Index as the first split of data. And again, if we have this data, we can use it to try to predict life expectancy, or the user would need to know the Human Development Index, the GDP, and schooling, and how much people spend on health as a percentage of their GDP. And they'll be able to use these diagrams to predict life expectancy. Okay, so that concludes this presentation for the life expectancy analysis. Thank you for listening.